Students, I hope you liked the previous video. Now in this video, we will discuss how to distribute a polynomial. Polynomials can be distributed two ways. First way, term-wise distribution, and the second is degree-wise distribution. We will discuss them one by one. Let us start with term-wise distribution. In term-wise distribution, we have to check the number of terms of polynomials. Number of unlike term. Here I specify on unlike term. If a polynomial contains one term, it is known as monomial. Now here is the example. 5x, it contains one term, that is 5x. So this is the example of a monomial. If a polynomial contains two terms, unlike term, I again focus on unlike term, 2x plus 3x, it is not a binomial. Because it is a like term, it becomes a 5x, so it is a monomial. As we have two terms, as you see here, 3x and 2, they are two different terms, that is unlike term, it is known as binomial. If a polynomial contains three terms, it is known as trinomial. Trinomial, you see that this is 5x square, this is plus 2x plus 2. This is the example of a trinomial which contains three terms. In any case, a polynomial contains four unlike terms. As in this case, we have four unlike terms. It is known as quadrinomial. You see the 2x cubed, 3x square, minus x plus 1. It contains four terms and they all are unlike terms, known as quadrinomial. Similarly, if it contains 5 terms, it is known as pentanomial. 6 term hexanomial. It is keep on increasing this way. Now another way through which we can distribute a polynomial, that is degree-wise distribution. So we discuss here degree-wise distribution. Degree of a polynomial is defined as the highest power of a variable. As in this case here, I just take the example of a polynomial. In this case, highest power of a variable 2x cubed minus 3x square minus x plus 1. In this case, the highest power of a variable is 3. So degree is 3. So this is the way we define degree of a polynomial. As in this case, x is for 4 plus 1, degree is 4. So highest power is defined as its degree. Now let us check its distribution. If a polynomial contains 0 degree, means number of a degree is 0, it is known as constant polynomial. As in this case, 5 is example of a constant polynomial because degree of a x is 0, and you know that the basic law of exponent says that x is to the power 0 is always equals to 1, as x is not equals to 0. Root 10, this is again a constant polynomial. Next is a linear polynomial. For linear polynomial, degree is 1. 3x plus 2. Example, x has a power 1. This is the example of a linear polynomial. If degree is 2, it is quadratic polynomial. Quadratic polynomial, as degree is 2. This is 5x square plus 2x plus 2. In this case, degree is 2. So this is the example of a quadratic polynomial. If degree is 3, it is cubic polynomial. As you see here, 2x cubed minus 3x square minus x plus 1. Highest power of a variable is 3. So degree is 3, known as cubic polynomial. Likewise, if the degree is 4, it is known as biquadratic polynomial. As here we have a biquadratic polynomial, x is to the power 4 plus 1, degree is 4. This is the example of a biquadratic polynomial. Biquadratic polynomial. Now let us discuss a few examples here. Now yes, there are certain important points that to be discussed. The first important point here, the degree of a zero polynomial is not defined. So before this, I will discuss here what is zero polynomial. The term 0, the number 0 is known as zero polynomial and its degree is not defined. We will explain this concept with a few examples. As I'm writing here 0 into x and as I'm writing here 0 into x, 0 into x always give you answer as 0, but check the degree of x, it is 1. In this case, in the first case, degree is 1 as 0x square. When we solve it, the answer is 0, but the degree is 2. Degree is 2. In the third case, I am taking example of 0x is to power 5. As in this case, degree is 5. Degree is 5. So you see that in the first case, degree of a zero polynomial comes to be 1. In the second case, it comes to be 2. And in the third case, it is 5. Due to this reason, the degrees keep on increasing. We cannot specify exact value of degree for the zero polynomial. So due to this reason, this zero polynomial, the degree of zero polynomial is not defined. Let us have a few more examples here that we will discuss here. This is an important example. If the degree of a polynomial is n, this is the second important point. The degree of a polynomial is n, then the number of unlike term of polynomial in the variable is n plus 1. It means the degree of a polynomial is supposed to be 10. Number of unlike term, it would be 11. We have an example for this. If p of x is x square plus x plus 1, you see the degree of a polynomial is 2. Degree of a polynomial is 2 and number of unlike term, it is 3. Maximum number of unlike term, it has to be 3. So maximum number of unlike term has to be 3. There are certainly some examples given in the NCERT. We will keep discussing those examples side by side. This is the question number 4 of your NCERT exercise. Here it is asked, write the degree of each of the following polynomial. As I stated earlier, the degree of a polynomial is the highest power of a variable. If you just look into the first example, highest power of a variable in the first case is 3. So what is the degree of this polynomial? Degree of this polynomial is 3. See, in the second case, this is 4 minus y square. So degree of this polynomial is 2. Third case, 5t minus root 7. Here this is the polynomial in term of t. So the highest power of a variable is 1. So degree of a polynomial is 1. Just look into the last example. In this case, you did not find any variable. So you can write x yourself and the x has a power 0. So this is the example of a constant polynomial with the degree of a polynomial is 0. So there are certain examples given in the NCERT. We have discussed those examples. We can discuss more examples like this. Now there's a more question in the NCERT. This is the question number 2, where it is asked, write the coefficient of x square in each of the following. Here the first question, coefficient of x square in each of the following. As I have discussed earlier, coefficient of x square means the constant term associated with x square. Constant term associated with the x square that we have to check in each of these expressions. Let us check the first one. This is 2 plus x square plus x. In this case, the constant term associated with the x square is 1. So the coefficient of x square is 1. Here in the second case, this is 2 minus x square plus x cube. In this case, the coefficient of x square is minus 1. In the third case, it is pi by 2 x square plus x and the coefficient of x square is pi by 2. Fourth case, you will not see any x square here. If you do not find any x square, it means the coefficient of x square is 0. because you can write here, you can even simply write here it is 0 plus 0 x square. You can write here 0 x square. It means the coefficient of a x square is equals to 0. So this is the way we find the coefficient of a x square in each of these cases. I hope you like this video. We will discuss more topic in the next.